Okay, welcome everyone, IEEE Computer Society members in Jordan and IEEE members in Jordan, our dear colleagues from the different Jordanian universities. Also, I would like to welcome you for this event. This is the third event for the Computer Society chapter in Jordan. Today we have our guest speaker and keynote speaker, Dr. Isabel Wagner, and she's gonna give us a workshop on data transparency and privacy. Let me introduce the speaker. Dr. Wagner is an associate professor in cybersecurity at the University of Basel, Switzerland. And Dr. Wagner received her PhD in engineering and M.Sc in computer science from the Department of Computer Science, University of Erlangen in 2010 and 2005, respectively. She is a member of the editorial boards of Elsevier Ad Hoc Networks, Computer Networks, and Computer Communications. She also serves on the technical program committee of several top conferences. She was recognized as a senior member of the ACM 2017 and IEEE 2018. Of course, her major research interest is in privacy and security in general. I don't want to take too much time introducing our speaker for today. And we apologize again for the delay that we had. And I would like to give the mic to Dr. Wagner and let her share her screen.
Thank you so much for the introduction. And big apologies from my side for the delay. All right, so can you see my screen now?
Yes.
Brilliant. So what I want to talk about today is concerning big tech and their insatiable hunger for data. And I will focus on two big parts. One is about how we can create more transparency for these big tech systems. And the other part is how we can build systems that are more privacy friendly. So to give a brief overview, I will briefly introduce big tech, the surveillance effects that their systems have, then talk about how we can create more transparency for these corporate surveillance systems, then look at how we can create more privacy-friendly solutions, and also discuss some open issues. So to begin with, let's just look at the word corporate surveillance. So corporate essentially means this is surveillance conducted by for-profit corporations. So it's different from state surveillance that countries might do to fight crime, to fight terrorism. But this is instead surveillance by companies that they do in order to support their business objectives, to earn more money. Then the surveillance part, it's tempting when you hear the word surveillance to think about CCTV. But actually, in the modern times, it's much more pervasive than CCTV cameras. Because if you think about surveillance on the web, this could include any kind of data about which websites we go to, how we interact with those websites, where we click, how long we stay, which links we follow. And based on that, we could try to guess which topics we're interested in, maybe whether we have any specific health issues or what our political opinions are. So it's quite far-reaching data. And the more we do online, of course, the more we are subject to this kind of surveillance. Just think about extending from the web to mobile applications. Then you have a device that you carry around, so you get location data in addition. So this can be very pervasive. So based on this phenomenon of corporate surveillance, some argue that a new form of capitalism has formed called surveillance capitalism. And this is really well argued in a book by Shoshana Zuboff from a couple years ago, where she says this new form of capitalism extracts data from users and from the social life of users, and then tries to first predict the behavior of users, and then also modify that behavior so that it serves the interest of the corporations. One example for that is when Facebook modifies their newsfeed to maximize the engagement of users, basically to maximize the time that users spend on Facebook. Now, there are two important concepts here, the two main themes of my talk, that are transparency and privacy. Now, it's important to be clear there that privacy is a thing that applies to human individuals. And if you look, for example, at the Universal Declaration of Human Rights, then this privacy concept is something that human individuals have a right to. And it's in this Universal Declaration of Human Rights, it's kind of has a really exposed position, right? It's there alongside other things like liberty of the person, like right to be free from torture, freedom of speech, all these kinds of things. So privacy is right up there with those. And the other concept is transparency, where the key idea is that companies and organizations of all kinds should be transparent so that they can be held accountable to the public which they serve. But the situation of this corporate surveillance and surveillance capitalism has resulted in a situation where individuals are becoming increasingly transparent to the corporations, and on the other side, corporate practices are largely hidden from public view. So it's kind of a reversal of this situation where individuals should have privacy and organizations should be transparent. So essentially, the situation is that we have big tech corporations, they collect lots of data, any data they can find really, and they attempt to use this data for their profit, but then of course they don't tell the users exactly what they do. So they try to be vague about what data they collect, whether they share it with other parties, and how specifically they use it. So if this was all benign, if there were no negative effects, then that would be nothing to worry about, right? But actually, undesirable effects of this corporate surveillance have been observed in the past already. And one of these is discrimination. Just one example here, which is about Facebook, that there could be many more examples. So Facebook had a mechanism that allowed advertisers to post ads where the ads are targeted in a discriminatory way. So you could put a housing ad, for example, but target that ad only at white people. Or you could post a job ad only for like young males. So these specific forms of targeting of advertisements happen to be illegal in the US. So that's what enabled the American Civil Liberties Union and a few others to file lawsuits against Facebook. And that dragged on for several years, actually, and was finally settled in 2019. And the settlement was basically that Facebook says, okay, we no longer allow targeting based on ethnicity, age, gender for ads in 3 specific categories: for job, finance, and housing ads. And the way that they realized that was that Facebook created a second advertising portal specifically for these 3 ad types, so for job, finance, and housing ads, which didn't have those targeting options. And the main advertising portal for all other ad types still had those targeting options. And then, of course, the duty to use the new advertising portal fell to the advertisers, and Facebook is the one to police whether they actually do that. So there is no independent verification whether this settlement has actually resulted in effective change. Another set of undesirable effects concerns essentially the democratic processes in countries. So one effect that researchers have observed is that corporate surveillance can help create and reinforce filter bubbles, where basically, let's say, users get search results from a search engine, and those search results are personalized. But we know that the ranking of search results is really important. Those results near the top receive almost all of the clicks, and even those at the bottom of the first result page receive very few clicks. So if those results are now personalized based on a user's profile, it could be the case that those results that reinforce a user's existing views, maybe existing political views, are always at the top. So they never get to see perspectives from the other side, so to speak. And then, of course, we have seen in the news with the Cambridge Analytica scandal that essentially micro-targeting of political ads can also influence democratic processes. So in that specific case, the thinking is that the Cambridge Analytica data helped influence the outcomes of a US presidential election and also of the Brexit vote in Europe. And there is also some research to substantiate this. For example, one study found that if you present slightly biased search results, then it is easy to influence undecided voters to essentially swing their vote to one direction or the other. And the Cambridge Analytica data basically enabled targeting of political ads specifically at those people who were presumably undecided. Okay, so another area where this corporate surveillance might be a concern is if you think about cities, and in particular smart cities. Smart cities are great, right? If they are realized properly, they have many benefits for citizens. Think lower commute times, no traffic jams, better provision with utilities, nice clean environment, good healthcare. You can do all of the interactions with your city government online. So it's great. But the question is, at what price this efficiency and convenience comes? Because the unfortunate situation is that if humans are subjected to constant surveillance, then that has impacts not only on the right to privacy, but on other human rights. So think about individual freedoms, maybe the freedom to assemble, but it also impacts human autonomy and even human development. So people who are under constant surveillance are less free to develop as a human. And that's really critical. If you think about the scale of surveillance that could happen in a smart city. And then to complicate that, citizens, they can't really opt out, right? In the web, you could argue, okay, then use an ad blocker, don't go to these websites, maybe leave your phone at home. But in the city, you can't just move away. Most people cannot. the workplace is in the city, maybe healthcare is in the city, all the entertainment and shopping facilities are there. So it's not really possible to just not go to the city. In addition, you could say that cities as public institutions have more of a duty to care about citizens' rights than, let's say, a private company that runs a single website. And yet what we observe in cities is that cities tend to outsource the technical infrastructure and often the operation of the smart city services to private companies. And it's easy to see why, right? Running new high-tech infrastructure and creating all these services is a lot of work and it takes a lot of expertise. And companies that offer to perform these services for the city can be very attractive. However, if they then provide these services and infrastructures at the price of, let's say, citizens' data, then it's more critical. So, okay, now I try to motivate that corporate surveillance exists and that it might be bad. Now, of course, the question is, how do we know? Like, how do we know how this corporate surveillance works and to what extent it is actually used? So the goal when we want to create more transparency for these corporate surveillance systems is basically to audit these systems to gather evidence of any harmful data practices that they might perform. So in order to do that, of course, we need to know, how does this corporate surveillance even work? Like, what technical mechanisms do they use? And then in the web context, specific examples for that might be tracking or profiling or advertising. But then, of course, the big question for researchers is how we even study those systems, because if you think about big tech like Google or Facebook or Apple or Amazon, researchers don't have any kind of privileged access to their systems. They don't get privileged access to internal data for sure. So basically, we need to study these systems from the outside, observing only data that flows from a user device to the big tech system. So now let's take a look first at the first bullet point group here and look at some examples of how corporate surveillance works. And then look at some examples how researchers have managed to study these systems. So if we look at tracking, for example, if websites engage in tracking, first thing they want to know is, for a specific user, when do they visit the website again? And also, which of our sub-sites do they visit? And then maybe if the company runs more than one website, they also want to know, well, do they only visit one of our websites or do they visit several different ones? And from that information, companies can try to build profiles about users. And these profiles, we'll see an example in a bit, they can be quite comprehensive, including interests, behavioral patterns, locations of users, financial data, health data, essentially all derived from the pattern of websites that a user visits. Now, there are two main mechanisms to perform this tracking. One is called stateful tracking, where basically some data is stored on the user system, so some state, and that's generally cookie-based. And usually how this works is that the cookies store an identifier for the user. And then the server has a database that for this identifier stores additional information. Let's say it stores timestamps when the user visited the website, or maybe stores search terms that the user used on that website. And then, so every time the user visits a website again, that cookie with the identifier is sent to the server, and the server can update their database. The other big method is stateless tracking, where there is no data on the user system. And the most common method here is called fingerprinting, where essentially the server tries to take a fingerprint of the user's browser. And this fingerprint is a combination of different attributes that the browser has that are visible from the server side. So, for example, the IP address, the screen resolution, which fonts are available in that browser, which browser extensions are installed. There are various different attributes. New ones are being proposed all the time. But the idea is that this fingerprint can then serve as the user identifier on the server side. So, of course, if a company uses stateful tracking, it's more certain because there is a cookie with a specific user identifier. So there is a guaranteed match between the cookie and the server-side database. But the user can also delete their cookies, and then that stateful tracking has a problem. Whereas stateless tracking, it's a little more probabilistic. The fingerprint can change over time. Maybe the user switches the screen resolution because they bought a new screen. Maybe they add a browser extension or add some fonts. So these fingerprints change over time, which means there is no guaranteed match to the server-side database. But the user is more powerless to do something about it because there is no data on the user system that they could delete. So this is tracking. Now, as I introduced it, it's very much focused on a single company. But the selection of websites that a single company offers is quite limited, usually, right? It would be much more interesting for the companies to know what users do on the websites that other companies run. But the problem is the cookies for company A and company B are different due to cookie security mechanisms. They can't read the cookies set by the other companies, so they don't know which of their identifiers refer to the same human being. And so what companies have come up with is a mechanism called cookie synchronization, which basically uses HTTP redirects, where if the users, let's say, requests a resource from one server, that server redirects to the other company's website, and in that redirect, they attach their cookie identifier. And then that website does the same thing and redirects back to the first one, and this time attaching their cookie identifier. And in that way, the two companies can make a matching table where they match the cookies, the cookie identifiers that refer to the same users. And then based on this matching table, they can exchange their server-side databases about the users just purely in the backend. So this exchange of data in the backend wouldn't be visible to the user. And from a company side, this is great because those two websites or those two trackers, they will see like a different share of websites. So if they can merge their databases, they will both expand their profiles of users. And it doesn't even matter if they can do this real time or not. Maybe they can only afford to do this data synchronization once a day. But even then, it benefits them by knowing more about each individual user. So I mentioned profiling and that we would take another look at what's in user profiles. So these are two examples. On the left is profile attributes maintained by Axiom, which is a big company in this space. On the right side, profile attributes maintained by Oracle. And you can see that this is really, really comprehensive. So on the Axiom side, there are health interests, phrased as interests, because maybe they don't know for sure that the user has diabetes just because they Googled diabetes-related search terms many times, but they know that maybe, if not the user themselves, maybe someone in their circle of relationships. So there are also attributes about political views, about religion, about age, gender, education, the number of children someone has, their financial situation in great detail, whether someone is interested in alcohol or tobacco, or in gaming and lottery. And on the Oracle side, you can see similar things, maybe some different focuses, but essentially put together, this is a highly detailed view of what these companies believe individual users, how the individuals' lives are like. And then, of course, this they can use to try to influence those users in some way or another. The easiest way to influence is, of course, to sell them ads that they might react to. So now that we know these mechanisms for tracking and for profiling, the next logical question really is, well, how much is there tracking on the web? Like, how prevalent is it really? So to find out, what we need to do is basically design some sort of experimental study and then collect data from a lot of websites and see what we find. And what you see here, this figure shows the blueprint for an experimental design for this. So as inputs, you have, let's say, the list of websites that you want to study. Then in the middle, you have this corporate surveillance system that you can't really look into, but you can collect some outputs from it. And in particular, those are the network requests and responses that the client's browser needs to render a website for the client. So you can collect this raw data and then use some algorithms to process this data, maybe to detect who owns specific domains, or which cookies identify users and which cookies are benign, maybe to detect which domains belong to trackers and which don't. And then based on that, you can calculate metrics like the prevalence of tracking or the reach, like how many different websites an individual tracking company can see. So over time, there have been several studies looking at that. So here are just two examples. Study one on the left was a longitudinal study where they looked at a relatively small set of websites, just 500, but over 20 years from 96 to 2016. And what they found is that sites, for example, that have 5 or more trackers embedded, only 5% of websites had at least 5 trackers in 2000, and that number went up to 40% in 2016. And then the reach of the best trackers also vastly increased. So in 2000, the best trackers saw under 10% of websites, whereas in 2016, it was already 60%. Now, if you think an individual tracker can see 60% of all websites, that means 60% of the browsing that you do most likely ends up in a single tracker's database. And that's quite a big percentage. So on the right-hand side, it was a bigger study, but only focused on one point in time. So they looked at 1 million websites. What they found is also interesting. They found basically the top 5 third-party domains embedded in websites. They all belong to Google. And in their case, the single most powerful tracker was Google Analytics, which was embedded in over 60% of websites. So essentially allowing Google quite a detailed look at what individual web users do all day long on the web. So now the other question is whether websites actually do something detrimental with that information that they learn from tracking. So to study this, one thing that you could look at is, well, do those user profiles really contain sensitive attributes? And would they use those sensitive attributes to target ads at specific users? And sensitive attributes here, I mean, roughly in the GDPR sense. So that's information about health or religious views or about ethnic origin or political opinions. So things that usually you would say, this is particularly, I would like to keep private and not known to everyone necessarily. So what this study found out is that 73% of Facebook users in the EU, which actually is 40% of the entire EU population. So they are assigned at least one sensitive attribute. So that's quite a share. And then couple that with the result that these sensitive attributes are targetable. So if you're an advertiser, you can say, I want to target this ad only at people of this particular religion, or only at people with this particular health condition. This is really quite powerful. So now these studies have all looked at transparency on the web. But of course, the technological progress doesn't stop at the web. And nowadays, we have other technologies that are also very relevant. We have the Internet of Things, for example, where people put devices like smart speakers or smart door locks, smart doorbells, smart heating systems into their homes. So studying their properties is actually much harder because 1 million websites, yeah, it's easy. You just basically free, you go there and visit them. But if you want to study 1 million Internet of Things devices, you actually have to buy those devices and put them somewhere. So it's a much more complicated experimental setup that researchers would be looking at to create transparency for these technologies. And even worse for smart cities, because individual services in specific smart cities might not be globally accessible. And that's probably a good thing. But for research, that means it's much harder to tell what individual cities do and whether they respect user privacy in their operations or not. Another big open issue in this space is that some of the big tech companies have attempted to obstruct transparency. Unfortunately, another Facebook example here. In this particular case, Facebook sued some researchers at a university in New York. These researchers were studying political ads on Facebook. And they used a browser extension to do that, which made it very clear to users what the privacy implications are. And yet Facebook claimed that this research violates the user privacy, also violates Facebook's terms of service. So they sued them and also terminated their personal accounts. And of course, whether Facebook was right with these claims or not, this is a deterrent in the first place, that other researchers may learn about and then say, okay, Facebook will sue me if I do this research, maybe I will study something else instead. So yeah, this is a tactic used by big tech companies that they can use because they have, well, they have a lot of resources, money to pay lawyers with, and so on, which tries to prevent research into them from happening. So I'll get back to this at the very end to maybe have an idea what we can do about this. But for now, let's move on and talk a little bit about privacy-friendly solutions. So basically, our goal here is we want to build a system that provides the service that we want it to provide, but at the same time respects user privacy. So we don't want to have a lesser service. We still want the same service quality, but we also want privacy at the same time. So to do this, there are some privacy enhancing technologies that have been proposed over the years. So we'll have a brief look at some examples, what their properties are, and then to make it a little more concrete, how they might be applied in a smart city scenario. So basically, if we think privacy, then the overarching principle is, well, we could minimize data. And that could take different forms, right? We could say we limit what data we collect. So for example, we could select sensors so that they don't collect excessive amounts of data. So if we, let's say, want intelligent street lighting that turns on when there are people and turns off to save energy otherwise, then we could use presence sensors instead of cameras that can detect individuals. We could also limit what kinds of data we store. So even if our sensors collect a lot, we could limit what gets stored. So for example, if we run a public Wi-Fi service, we could consider whether, even if we have access to it, whether we store logs of user activity or not. And then, of course, we can also put limits to the data processing. And one idea there is, if we have to have devices with rich sensors, maybe we can process that data on the device directly and discard the raw data. So let's say we have an entertainment district in a city where we want to have some sort of audio surveillance so we can detect whether fights are breaking out. Then these audio sensors might be capable of capturing all kinds of sensitive conversations. So maybe we can process the audio streams on the device and only send on like a flag, fight is breaking out now, or all quiet. And that way, no sensitive data even gets to systems that could store them. So in addition to these kind of basic techniques, privacy enhancing technologies maybe provide more advanced possibilities for minimizing what can be done with data. So two examples that we'll look at are zero knowledge proofs and anonymous credentials. The problem is that the current mentality is different. right? Instead of minimizing data, the current mentality is, oh, we can collect this data, great, maybe we can do something with it later. So mentality is just collect everything that you can, and maybe it will turn out to be useful at some point. This is an aspect that we'll get back to at the end, but this is one reason why maybe privacy technologies are not quite as commonly used as they could be. Okay, so let's look at one particular use case that we might have. And that is, maybe we have some nice data set that we want to publish so that others can derive some use from that. A specific example for that is if you have public transport data of when people take public transport and where do they get on and where do they get off. That might be useful information for all kinds of businesses, maybe to determine the opening hours of their stores, or any other scenario you can think of. So the idea there is we want to publish this data, but we don't want that people can find out individuals in that data release and tell what these individuals have been doing. So for that, a relatively old approach was called anonymity, where the idea was that we take our database and then we look at the rows and try to group them so that each individual has a k-1 other individuals with similar attributes. And to do that, maybe we modify our database rows a little bit or remove some. The problem with that is that it's been shown to be broken many times. So even if you k-anonymize a database, there are still useful things an attacker could find out. A newer approach for that is called differential privacy. And there are two settings for that. The original setting is that you have a database in the hands of a trusted provider, and people can ask queries to the database. And then those queries should be similar. You should be giving a similar result, regardless of whether a specific individual is in the data or not. And in that way, the privacy of all the individuals is protected. And you can modify that for data publishing, where then the idea becomes that you protect whatever contributions each individual has made to the data set. And this is actually practically usable in both of those settings. And the data publishing setting, one example is, as I said, public transport data. The city of Sydney has published public transport data using differential privacy as a protection. And basically what they did is they aggregated data first so that they had like 15-minute periods, and then released counts for each public transport stop. And to these counts, they added noise according to differential privacy. Okay, so aside from releasing data, another thing that a problem with releasing data is that it can be really hard, especially if you have very fine-grained data. Let's say you have a location trace. So if you think about the Sydney example, right? They aggregate to 15-minute periods, and then they release data for each public transport stop. But if you think about like the trace that a car moves through the city, that's much harder to anonymize. So the idea there is maybe you don't need to publish real data for the data to be useful. But maybe it's sufficient to publish synthetic data. And a a commonly used technique there at the moment is to use machine learning to use machine learning models to generate data that looks similar to training data. So the principle is sort of what you see on the right here. You have one model marked with G, which generates data samples. And initially, those are just random. And then you have a second model, the discriminator, which is trained to tell real data samples from fake samples. And the output of the discriminator then goes back to the generator. And based on that, the generator learns to generate better and better data. So here you could say, well, the generator never sees the training data. And therefore, this preserves privacy. But unfortunately, that's not the case. There have been many known attacks proposed in the last 2 years, where, for example, someone could infer whether specific individuals are in the training data or not. So the current thinking in academia here is that you can add differential privacy guarantees to the synthetic data generation. But that is still a hot research topic. There are still different approaches, how best to set it up, hard to tune the parameters. So this is where a lot of research happens at the moment. So another thing that might be relevant in a smart city is if users of the city could convince the system that they did something correctly. So, for example, if you have, if you want to take tolls for road usage, then you might have, as in the picture on the top, you might have these toll gates like in Singapore, which basically record which car drives under them and when, and then on the server side, they can calculate the tolls. You can also do this based on zero-knowledge proofs, where the car cryptographically can convince the toll system that they have correctly calculated the toll that they need to pay. And then they tell the toll system how much they need to pay. And the toll system only learns the amount, but doesn't learn which road sections an individual has driven on. So this is cryptographically sound. It exists on paper. I'm not aware that it exists in any real-world toll system. There is a similar approach that is available for smart metering, and that smart metering approach has even been implemented on real smart meters. But in the real world, for example, in the UK, when it came time to decide the specifics of the smart meter rollout, the government chose the version that isn't privacy preserving over the one that is privacy preserving, unfortunately. Another thing that you might want to do in a smart city is to do with authentication. Maybe, well, individuals need to prove that they are allowed to use a specific service. Maybe you want to give public transport discounts to students, or maybe you want to mandate a certain age to purchase alcohol in a store. And the traditional way to do that is, of course, you show your real ID, and then the service provider learns all kinds of things, learns your name, your date of birth, whatever else is on the ID, which most of that is information that they don't really need to make the decision whether you're eligible to buy or eligible for a discount. So the idea with anonymous credentials is that using some form of smart card, you can, as an individual, selectively reveal facts about yourself that the seller can be convinced by way of cryptography that are real facts about yourself, but without revealing your identity at the same time. And also with the nice property that the seller or the city authority can't link individual people to the purchases they make, or a purchase in one store to a purchase in another store. So this technology proposed, I don't know, more than 2 decades ago, is at a point where there are prototypes available, software development kits available. There are just some of the logos at the bottom here, but their real-world use is still very limited. So that brings me to talking about some open issues with these privacy-friendly solutions. I've shown just very few examples of privacy technologies. There are many more. And in the end, combinations of these would probably be sufficient to solve most of the privacy issues in smart cities. One problem is, of course, they are not trivial. And many of these solutions are not at the level of just maybe adding a library to your software development to take care of the privacy issues. So they do take knowledge and skill in this area to apply correctly. And then, of course, especially in the smart city space, there are massive real-world pressures. Finding a privacy engineer can be difficult. Maybe hiring one will be expensive. Maybe building a privacy-preserving solution would be more expensive, would take more time than a non-privacy preserving one. And the flip side of that is that private companies might offer smart city solutions for very low cost that can do amazing things in exchange for just slightly access to the user data. And given this situation, the financial situation that many cities are in, it's clear why the offer from private companies sounds really attractive. So to conclude, so what I've shown you in this talk is basically, I've talked a bit about what corporate surveillance is, and I've shown you some specific negative effects, including discrimination and tampering with democratic processes. Then I've shown you the extent to which corporate surveillance is actually present on the web, and we've seen that it's quite widespread, and also that sensitive data derived from this tracking is used for targeted advertising. And then in the second part, I've shown you that privacy-friendly solutions are indeed available, just not used very much. Now, looking ahead, it's increasingly the case that users are more and more concerned about data collection practices. And they get especially concerned when things appear creepy. Like they get ads corresponding to a conversation they had the last day. So this increasing concern on the user side might actually create a business case to implement more privacy-friendly solutions. But then on the side of the academics, this means we actually need to train computer science students so that they can become those privacy engineers to implement those solutions one day in their workplace. If we don't train people to consider privacy and know about the solutions that are there, then it will be very hard to have them implemented in the real world. The second aspect is related to transparency and the increasing obstruction by big tech to try to prevent studies of them, where the thing is that transparency is really important to hold big tech to account. And transparency that researchers can create is at a quite detailed technical level that is an important complement to anything that can be created in the legal realm. So it's really important that researchers continue to be allowed to study these corporate surveillance phenomena. To ensure that they indeed are allowed, maybe it's the case that we need more regulations in some form that mandate platforms, they have to be open to be researched. So with these words, I'm concluding my talk and look forward to your questions.
Thank you so much, Dr. Wagner, for this informative talk. We really appreciate your time and your effort. We have one question from, or two questions, I think. One question from Dr. Yusuf Jaradat, in which he says, how to mitigate corporate surveillance from the user side? Like he suggested using, for example, Tor browser, for example, can it eliminate such tracking on the web?
Yeah, Tor browser is an excellent example. Yeah, so there are a few options. Probably the simplest option is an ad blocker, because the nice side effect of an ad blocker is that much of the tracking comes through advertising, and so if you block the advertising, much of the tracking goes away. Ad blockers don't do much against this stateless tracking via fingerprinting. And that's an example where Tor browser is really, really good. Because in addition to providing anonymity via the Tor network, Tor browser implements a whole series of countermeasures against this fingerprinting. Yeah, so that definitely helps. The problem, where it becomes complicated is when you look at mobile devices. Tor is available on mobile devices by now, easy to use. So that's a good thing. But if you think about ad blockers, then individual mobile apps, you can't just install an ad blocker into them. So that's a little difficult. And then if you go to Internet of Things devices, it becomes even more difficult. So I think to date, we don't have an effective ad blocker for, let's say, your smart TV. So there is still more research to be done.
Okay, thank you. Another question that we have from Professor Raith Abanda. He says, could you please give us an example or examples how corporate surveillance in smart cities can be harmful to the city's citizens?
Yeah, so there are a few ways. So one way is, so let's say as a smart city example, we look at traffic optimization. So if the city realizes that with cameras, maybe those camera images go to third parties. And if those third parties have some compute power, maybe they can recognize license plates, and then maybe by that they can track individuals through the city. So this can contain very sensitive information, right? If the individual drives to their church or to a hospital, or even just from home to work, those are interesting locations that maybe a corporation would be interested in. So then they can target ads in a discriminatory way at the individual. So that's one way how corporate surveillance in a smart city might become harmful. Another way that actually has happened in the past is there was a case where a city wanted to have sensors on their street lights to measure things like air quality and so on. So in their contracts, the corporations actually owned the data that those sensors generated, even though the streetlights were city property. And then at some point, that corporation was, I don't know, it became bankrupt or it was sold. So suddenly another company asserted ownership of that data and refused to provide the data to the city. So now suddenly the city used to have air quality measurements and now it doesn't have it anymore. So in this example, citizens are not really harmed individually, but on the collective basis that the service that used to be provided suddenly either went away or became more expensive.
Okay, thank you so much. We have another question from Dr. Omar Al-Qadi. How can different privacy regulations between different countries be aligned? Example, a comprehensive data privacy law to all data types does not exist between Europe and the US. Such privacy regulations does not even exist in many developing countries.
Yeah, that's a really good question. I've seen a figure recently how many countries have data protection regulation. It's actually a sizable amount by now. I would say something like 3/4 of all countries have regulations. But as you said, they are not really aligned. I'm not sure how to solve that issue, to be honest. I think the EU tried in the sense that they said the general data protection regulation applies to all companies whenever they process data about Europeans. So in a sense, they expanded their reach to companies worldwide to whenever they were processing data about European citizens. But in reality, I'm not really sure how effective that move was, especially as you mentioned, that example with Europe and the US and the various treaties between Europe and the US concerning privacy frameworks and data exchange being declared invalid by courts. I mean, from a privacy fundamentalist perspective, it's all easy, right? If everyone did everything in a privacy preserving proper way, we wouldn't have a problem. But the real world is not that, unfortunately. So yeah, it's a hard question. And I suppose it's also a hard question for people who really are familiar with things like international law. So, well, maybe we do need just more easy to use technical solutions that also allow citizens to protect themselves regardless of where they are. And then these regulations will matter less.
Thank you for the answer. Another question from Dr. Omar. Privacy and technology. We live in an era of data analytics. How can we reveal new insights and innovations to advance progress while preserve privacy?
Yeah, this is also a very good question. There is research in this area. For example, one area looks at how we can distribute machine learning so that the approach is called federated learning, where the idea is that you can train a machine learning model locally and then add some privacy protections to your local model and then share it with others. And in that way, you can train models on very large amounts of data without having to centralize that data in the first place. And I think that's quite a promising approach to solve some of these data analytics issues. And I think in addition to that, there are also data analytics approaches that are not really based on machine learning. So there's also work on those. And in that realm, it's often a case that you can, for example, apply differential privacy locally on a system and then share that data quite freely. And then a central system can still derive insights from the data, but doesn't learn much information about the individual.
Okay, thank you. Another question from Dr. Yusuf Jardat. He says, users sometimes are helping corporates to monitor them by accepting cookies and other stuff like online consents from various websites. Is there any technique to help users in such issues? We always tend to press the agree button.
Yeah, and that is by design, right? The companies design their cookie banners in such a way that the agree button is the most easy one to press. And if you don't want to agree, you need to at least press 2 buttons and you need to think about it, and it's hard. So I'm actually not 100% up to date on whether there are now extensions, like browser extensions, think an ad blocker, but for cookie banners, in the sense that they would parse those cookie banners and press the most privacy-preserving version. That seems feasible, but I don't know whether such extensions exist at the moment. Another option that also doesn't exist, but it might exist at some point because of recent advances in research, is that you could have a machine learning model that can read the privacy policy of a website, extract all the data practices that are described there, and then match those locally on your system with the privacy preferences that you maybe have specified once. And then you could make a browser plugin again that either tells the user if there's a mismatch between what the privacy policy offers and what the user preferences are, or uses some combination of blocking and indicating consents via the cookie banner to express to the website what the user wants. So the problem is that these are possible solutions that might exist at some point, but I don't think they exist right now.
Okay, thank you. Another question from Professor Andraus Swaidan. Do you think that government bodies are more ethical than corporates?
That's a nice question. I would like to think so, but then 2 scandals later, I'm always doubting whether I'm right. I think there is not just one government body, right? So maybe the lawmakers are interested in protecting user rights and make the correct laws, but then they are also subject to pressures. And one of these pressures comes from the police type organizations or the national security type organizations that say, oh, we need these exceptions, otherwise bad things will happen to the country. So then maybe as a result, you get exceptions in laws that are more far-reaching than they need to be. And then maybe you also get behavior from police and national security type bodies that doesn't conform to laws. So I think with government bodies, it's a mix where overall, I think there is more of an interest in user rights. Whereas corporations, with the way, especially with the way that business models on the web have evolved over the years, to the point where basically it's all advertising revenue based, right? So all corporations on the web have an interest in maximizing their profits and therefore in learning as much as possible about users. So it's sort of in their ingrained in their self-preservation to not care about user privacy. So in that sense, I think governments are in a better position.
Okay, thank you. We can maybe take 2 more questions and then we can conclude. I have a question actually about Facebook. When you said that Facebook is suing researchers because they are using data. So here you're talking about data collected through add-ons in Facebook and Facebook applications that the researchers add to Facebook, or data that they are trying to get directly from Facebook as a company?
In this specific case, the researchers had a browser extension, and that browser extension users could use to send political ads to the researchers. So it was data collected from Facebook via a browser extension.
Okay.
Yeah.
Last question from Dr. Yusuf Jaradat also. He's asking about the future. Quantum computing is coming. Security and privacy are compromised. Do you think post-quantum privacy techniques are available?
Yeah. No. So I think there is a lot of work on the security side for post-quantum. And to the extent that privacy relies on security mechanisms, that means we're getting to be in at a good point. To the extent where, so we could think about new attacks maybe that are enabled by quantum computing, and to the extent that those attacks maybe compromise privacy, I don't think there's any work really in that area at the moment.
Okay, thank you very much for joining us and for this very informative session, Dr. Wagner.
Thank you very much for the invitation.
Yeah, and I would also like to thank our participants from Jordan, IEEE community, and research and universities community. And Dr. Raif, do you like to add anything?
I'd like to thank you, Isabel, again for joining us. It was very informative talk, and I have enjoyed it. I'm sorry again for our members because of the delay in this talk. We have lost some of our participants, but I hope that if you don't mind, we're going to post the recording of this workshop to them, and I hope that they can watch it at their convenience. So thank you again, and I'd like to thank all participants for their interesting contributions. Thank you and good night.
Thank you.
Okay. Thank you so much, and maybe we'll see you in the future in other events.
Thank you all. Thank you. Bye.